All right, question number 1 from practice exam 2. This problem deals with this Mancala board game. It's played between two players. If you look at the page 175, they kind of give a brief description of what's going on. I'll try and explain it just a little bit, make sure you're clear on this. It says the board has 12 small pits called houses, 2 large pits called stores, and they give you this little diagram here where you've got 6 of these pits on each side. Obviously, if you've played the game, this will make sense. If you've not, hopefully by reading or just listening to the description, it will make sense to you. So it says at the beginning, the same number of seeds, like 3, for example, is what they use in the text here, placed in each house, and the stores are left empty. And each player controls the 6 houses on their side of the board and the store to the right of their houses. So if we're looking at this, let's say that player 1 is right here, player 2 is up here. So player 2 controls these 6 houses and the store to their right. Player 1 controls these 6 houses and the store to their right. And it says that the Java class Mancala is used in the implementation of the game. In this question, we're going to be asked to write the constructor and one method of that class. The board is represented as an integer array called board. In the example we're looking at here, based off the sketch here, this would have 14 elements. So you've got the 12 houses, 6 and 6, and then the 2 stores. So that would have 14 elements. The first player's houses are represented by the elements from 1 to 6, those indexes. So they list the first house as index 1, 2, 3, 4, 5, 6, and then their store is at index 7. Then if we go up here to player 2's values, they're stored at their houses and store are at position 8 through 12, 8, 9, 10, 11, 12, excuse me, through 13. And then their store is considered 0, so that's sort of the wraparound point. So the store for player 2 is always the first element in the index, then the first player's houses, then the first person's store, and then you fill out the rest of the array with the second player's houses. So a little interesting the way they set this up. You would almost think you could just go from 0 to 6 this way, 0, 1, 2, 3, 4, 5, and then 6 being this store, and then go 7 through 13, so that you're kind of splitting it up even, but this is the way they have it set up. And then it says the constants, this is the last line on page 175, the constants and instance variables of the Mancala class are shown below. So you actually have to flip to the next page, and they have this brief description of the Mancala class. So I'm just going to write down the basics of this class. I probably won't write down every detail. We have a private static final integer variable called board size. So I'm not going to write out all of the header files or all of the the descriptions of this variable. But we do know that we have this board size and it's set equal to 14 to represent how many spaces we have. The reason that you usually would make something like this in your code, even if you know it's a certain value, is this allows us the flexibility to change the board size. And all we would have to do is change this one variable, and then the rest of the code will adjust to still work. So you could technically have a board that has, I don't know, 10 houses on each side. So it just allows some flexibility in your game. And then we also have the indices of the stores. Those are listed. Again, I'm leaving part of the descriptions of these off. The accessibility, whether it's public or private, obviously these are instance variables, these will be private, as well as the static and final words, just to save some space here. So store 1 is located at the index board size divided by 2. So let's check this out and see how this works. So what is our board size? It's 14. So if I divide that by 2, that gives me 7. That puts me at the position of this store, okay, the store for player 1. And then if we look at the diagram here, player 2's store, well, that's back at position 0. Okay, so those are just set up that way. So if we ever want to refer to where store 1 is, we just call store 1. We want to refer to where store 2 is, we call store 2. Again, those represent the indexes, not the actual value in the array, okay, which will be how many seeds are in those places. And then finally we have this private integer array called board. Alright, so this is sort of the setup to the file. There's some other information. It gives us a little dot there to indicate that we have some other code possibly, but this is just sort of the setup for what we see. So we have these three final instance variables: board size, store 1 and store 2, and then this integer array to represent the board. They tell us that throughout our solution we should use the symbolic constants using these phrases: board size, store 1, store 2, and so on, rather than the literal constants. So as opposed to actually using the values, the actual numbers like 7 or 0 or 14, we're going to refer to those values using these constant variables. So at this point we're going to begin writing the constructor for the class. It takes one integer parameter n and initializes the board by placing n seeds in each house, and then it leaves the stores empty. So that's all they tell us. They tell us to complete the class below. So notice board is declared as an integer array, but to actually build the space and memory we need to initialize that. We need to actually build this integer array using that new keyword like we normally do when we build new objects. Okay, so what we're going to do, I'm going to shift this down just a little bit. Is we're going to begin our class. So this is actually beginning part A. Public Mancala. That's all we need for the constructor because the name of the class is Mancala, no return type. And then it takes in one parameter, which is going to be the number of seeds we want to put in each house. Alright, let's scoop this up just a little bit more. So, first thing we need to do is we need to set up the memory for this integer array, for this board we're building. So we refer to the name of the variable that we've declared. We called it board. And now we want to actually set up the memory, build the array. So we use the keyword new, and we tell the data type, and then inside the brackets we tell how big, how many spaces we need for this array. So think about it. If we are building this board that we're looking at right here, how many spaces do we need to represent all the houses and the stores? Well, we're going to need 12 houses, 2 stores. That means we need 14. That's why we made this variable board size. Okay, so if I want to actually implement this constructor, use that board size to say that we want to build an integer array, then I'm going to say just figure out what board size is, which is 14, and add that many spots in the array. Okay, so that is initializing it. I guarantee you that's going to be at least one point for this problem. So then we want to go through and place n seeds into each house. So remember, each element is going to hold an integer. Each position in this array holds an integer, so that's going to represent how many seeds are at that spot of the board. So I just want to go through all the spots. There's a couple ways I could do this. I could go through all the spots that aren't stores and put n seeds there, because if you remember, by default, when we build a new array that's holding primitive data like an integer or a double, what is the value that those begin with? Every time you build a new array, if it holds integers or doubles, the value that is stored there at the beginning is going to be 0 by default. If you were to build this using booleans, then they would all start off to be false. So that's what happens with our 3 primitive types. Integers and doubles default to 0 for each spot. Booleans default to false at each spot. If we built this out of objects, like strings, or I don't know, maybe you make a class for a board or for a position. I mean, you could make any class, any type of object you want. They would default to null. Okay, so they would just be null stored in each spot. So right now these are all set to 0. So what I can do is either go through and just find all the ones that aren't a store, set those equal to n, leave the stores at 0 because the store should be empty. It says in the description. Or I can go through and make them all equal to n, and then just go back and once again turn the stores into 0. And to me, that's really probably the easiest way to go through this. So what I want to do is just simply navigate through the array and think about this. I want to change the value at each position to go from 0 seeds to n seeds. We want to put that many seeds in each spot. So since I'm changing data, should I use a for each or a standard for loop? The correct answer is we want to use a standard for loop whenever we're changing the values stored at those positions. Okay, so to use a standard for loop, I need a variable to keep track of where I am. So I usually just use I to represent the index for where I am. I'm going to start at position 0 and go up to basically want to go through all the spots. So there are 14 spots that stored as board size, so the last position is at position 13. So as long as I have not reached 14, as long as I am less than the board size, we want to keep going through this loop. And then as soon as we finished handling each position, we want to go to the next position, so we will say I++ to move to the next spot. So this is going to be really straightforward, really simple. What do we want to do once we reach a spot on the board? We want to change its value. So the name of our array was board. If I want to change a value at a certain position, I use the bracket notation. So that means go to position I in the array, called board. And to change its value, we just set it equal to what we want to be placed there. Well, we want to go to that spot and set it, place n seeds into each house. So I'm just going to set the value equal to whatever n is. And I want to do that for every single spot. So that includes the stores. Okay? Now, the message, the comment said to leave the stores empty. So since I put n seeds in all of them, I just need to go back to those two stores and set their values to 0. And if you look on your paper, or you can look here on the screen, the indices, for the stores, where they are located, are actually labeled store 1 and store 2. So position 7 is store 1, position 0 is store 2. That's what this part was for. So if I want to go to that position and make this accessible in case we change the board size, all I want to do is say go to the board at position store 1, and when I found the position at store 1, I want to set it equal to 0. I want that store to be empty. And then I want to do the same thing for store 2. Make it empty. Okay? So, a little more discussion on this problem. That's actually all we need to do. We've put n seeds in all the stores, went back and made, in all the spots, went back and made the stores empty. So we've accomplished the purpose. Initialize the board and then set the correct values. So a little longer maybe here discussing the problem, discussing the setup here, but hopefully it makes a little more sense so that this constructor to actually build a Mancala board makes sense to you. So that's part A. We're now going to move on to part B, which is actually the steps of the game where a player moves the seeds. They take all the seeds from one of their houses and they sow them by moving them to different spots along the board. And then there are some other conditions we need to take into account to decide if the person gets another turn or if they don't get another turn. Okay? So move on to part B. Check that out. Again, if you have questions, you can leave a comment or send me an email or just talk to me in class, and we'll try and address those. Thanks.